Hello viewers, welcome back to another section of my tutorial, and we're going to solve the Bernoulli's principle application problem. This is an aeroplane problem. So in our previous video we solved about the heart, that's about medical engineering field, and now we are dealing with aeroplane. We did about the tank also. So if this is your first time visiting this channel, kindly subscribe, you like, and also you get access to all our previous tutorials. Now, he said an aeroplane wing is designed so that the speed of the air across the top of the wing is 251 meters per second, when the speed of the air below the wing is 225 meters per second. The density of air is 1.29 kilogram per meter cube. What is the lifting force on the wing of area 24 meters squared? You can pause the video and try your hands on this problem. If not, let's continue solving this. So we are having an aeroplane. Try and make some diagram. So as you have an aeroplane here, so you realize that he said the wing is designed so that the speed of air across the top is always 251 when the speed of air below is 225. So right now the problem we are dealing with is centered on what? Horizontal distance. It has nothing to do with height or the level the aeroplane has reached in the sky. So let's see. We write our Bernoulli's equation P1 plus half rho V1 squared plus rho Hg, rho H1 should be equal to P2 plus half rho V2 squared plus rho H2g. Once I have this, you realize the question was centered on the velocity of air, which has a direction horizontally. So in this sense, this term here will vanish because the change in height of the aeroplane is 0. So I'm going to have P1. So it is asking us to find force. Remember, in the Bernoulli's equation we don't have a force, but we have pressure, which can give us force given an area. So what is the lifting force on the ring of area? So meaning we need to determine the pressure, that is the change in pressure, before we can use that to find the force. So P1 minus P2, which is my change in pressure, is going to be half rho V2 squared minus half rho V1 squared. So P1 minus P2 will be equal to half my density of air out, then V2 squared minus V1 squared. So with this, I'll get half multiplying 1.29, then V2 squared 225 squared minus 251 squared. The bigger one will come first, minus 225 squared. What am I getting for this simplification? 0.5 times 1.29 times 251 squared minus 225 squared. And that is giving me 7,982.5 Newton per meter squared. So this is my pressure. This is my pressure, change in pressure. And he said the question is actually asking us to find what is the lifting force on the wing of area 24 meters squared. Pressure, as we know, is equal to force over area. And the force now is what we want. So my force is simply going to be pressure times what? The area. Area was given in the question as 24 meters squared. Therefore, my force is simply equal to the 7,982.52 by the area 24. And what am I getting? 7982.52 times 24. And that is giving me 191580.48. Area is Newton. Sorry, the force is Newton. And you can bear with me that this force is enough to cause the lifting of the aeroplane. So applying Bernoulli's principle here, we've been able to find the pressure, and through pressure we found the force. So whenever they give Bernoulli's problem, remember you ask yourself, what do I want? I want a force. But the Bernoulli's principle, there is no force term in it, meaning through pressure we can get force. Thanks for watching this video, and if you found this video helpful, don't forget to like and subscribe.